Hello students, so today we'll continue with the same chapter, algorithms and flowcharts. Keep in mind that this chapter is equally important, though it may be a short chapter, but programmers use these algorithms and flowcharts before they actually build the programs. So you need to understand how to write down algorithms and draw flowcharts before you build up the programs. So a slight recap of what is an algorithm. An algorithm is a finite set of instructions used to solve a certain problem. It is used by the programmers to solve programming problems before writing the source code. So here I have written an algorithm to find the simple interest. In the previous video also I have explained two algorithms. So here you can see that the step 1 is start, and in the second step you enter the value for the principal amount, rate of interest, and number of years. So I'm sure that you are familiar with the simple interest formula. So as you can see that the formula that is executed here is almost the same as you use in your maths formula. So after you enter the value in these variables, the next step is to execute the formula, right? Then after executing the formula you have to print the results. So this is how it is displayed in this step by step. So as you can see that the steps are written in simple English sentences, so that programmers and non-programmers also, just by reading through these steps, they can understand easily what this program concept is going to be about. Okay, so in step 3 you can see that calculate simple interest using the formula. Simple interest equals to principal amount into rate of interest into number of years divided by 100. And in step 4 you just have to print the simple interest result. And finally step 5 you stop the program. So this is how you write down an algorithm before you actually start doing the program. So by this you can make some changes if there is any errors in the program or you want to modify the program. Now next, another algorithm to find the greatest out of three numbers. So this you suppose you have three numbers, that is 5, 6, 7. So you have to make comparisons between those numbers and find out which is the greater number. So in step 1 you start. In step 2 input three numbers A, B and C. So three variables here are declared, that is A, B and C, and in these three variables you'll be entering the three values, that is suppose like 5, 6 and 7. As you know that a variable can store only one value, right? So that's why you have to declare three variables. So after you declare the variables and you enter the values and store it in A, B and C, the next step is to process the formula, right? So you can see here in step 3, if A is greater than B and A is greater than C, then step 4, else step 5. So what is this? So this if keyword is used to compare the relation between this A and B, comparison. So always when you are so you can see that this is a Boolean expression. So here you are using the relational operator greater than. So you're comparing between these two variables, the values stored in these two variables A and B. So when you have to compare the two values, then you always use this if keyword, and based on that, or if you have to use with a relational operator. So this is a relational operator and this is a logical operator. So when you use the relational operator or logical operator, you always use this if keyword, which is explained in the next chapter. So keep in mind that the outcome of this test condition will be a Boolean. This is a Boolean expression, so the outcome of this test condition will be either true or false. So based on the true or false, the other steps will be executed. So here, if suppose A value is if A value is 7 and B value is 6, so 7 is greater than 6, yes, and 7 is greater than suppose 5, yes, then go to step 4. So step 4 will be print A is greater number, and then go to step 8, so it will stop the program, because since after comparing here both this expression must be true. Since this is a logical operator, the if test condition is testing this relational expression and this relational expression. So in a logical operator, both the left and the right side of the expression of the relational expression must be true. Only if A is greater than B and A is greater than C, then it will go to step 4 and display the result, print A is greater number. Then after that you need to go to step 8, that is stop. Otherwise, if suppose the value of A is 5 is greater than 6, no. 5 is greater than 7, no. then it will go to step 5, that means here. So this step 4 will be skipped because a is not greater, right? So step 4 will be skipped and it will move on to step 5, which is again another comparison will be made. B is greater than C and B is greater than A. If suppose B is greater than C but B is not greater than A, then it will go to step 7. So when you use the if test expression, if construct, this else keyword will also be used. That is, if these two test expressions turns out to be false, there need to be an alternative output, a result. So that is taken care by this else. So that is, if the value of B is not greater than C and if the value of B is not greater than A, then else you move on to a different step, then it will produce a different output. But if suppose here B is greater than C and B is greater than A, then step 6 will print out B is greater number and then finally go to step 8, stop. But let's say that B is 6, so B is greater than C, 7, no. But B is greater than 5, yes. But in logical operator, both the sides of the expression must be true. Since one side is false, so B is not greater and it will print out C is greater number. Clear? So when you do the actual C++ program also, the formula logic will be similar to this. However, you will not be writing down in C++ program this step 4, step 5 like that. For that, you will be using a different syntax, a different structure. Now, flowcharts. So flowchart is a pictorial diagram that uses different shapes of boxes to represent different parts of the program and arrows to connect and show sequence to different events in the programs. So flowcharts are drawn using symbols such as rectangles, diamonds, ovals, small circles, and arrows. Arrows are called as flow lines. That is, direction arrows are called as flow lines. So programmers, they use these flowcharts to create step-by-step solution of the program problem. It is one of the easiest and shortest way to create and find solutions to the problem. Alright, so these programmers, programmers, before they write the program, they can use either the algorithms or the flowcharts to find an easy or short way to find the solution to the problem. So mostly programmers, they use the algorithms and flowcharts before they build up the actual program. So using these flowcharts also, they use some symbols like the rectangles and diamonds like that to represent the program structure flow. Now, different symbols that you use to make flowcharts. The first one is terminal box or oval shape. So this terminal box is used to mark the beginning and end of the flowcharts. So just like algorithms, flowchart has only one start and one stop, and only one arrow line can be used from the start symbol. So when you start the flowchart, only one arrow symbol will start from the start symbol. So you can see that this oval shape is used to represent the start of the program and stopping of the program. Alright, so when you see this oval shape, it means that the program starts here and the program will stop here. Now, to represent input-output symbols, a parallelogram is used. So this symbol is used in two ways: to show or accept input values from the user, or to show the output results. So when you are entering the values, you use this symbol, or when you have to initialize and show the values, suppose A equals to 10, B equals to 10, C equals to 20, then you can use these symbols. Or when you have to display the value after processing is done, then you use this symbol. Alright, now process or rectangle. So this symbol is used to show the processing of the program logic. Here the formula calculations and computations are shown or done. So here in this rectangular box, you can see that the formula that is executed, suppose sum of two numbers. So the sum of two numbers formula will be executed in these rectangular boxes. Clear? So after inputting the value, the processing will be done here. Now decision box or rhombus or diamond. So this symbol is used when some conditions has to be tested. So in the previous algorithm, you have seen the if A is greater than B, A is greater than C. So that decision making condition is done in this diamond shaped box. So and the Boolean expression condition always evaluates to two answers. So this is actually a Boolean expression which is based on two types of answer, that is true or false. This symbol has one entry point and two exit point, that is one yes uh, one yes entry point, okay, one yes exit point and one no exit point. So based on the decision condition, the processing will choose either yes or no. So the entry point denotes the input value entered. So from here, the value of A and B will be entered and accepted here. So after that, the comparison will be done. If it is found to be true, if A is greater than B, then it will go to this yes exit point and it will process the whatever is written here. And if it is found to be false, it will go to no part, and suppose like it may be an else option. If yes, else, like that. Now direction arrows or flow lines. This symbol is used to show the sequence of the program flow. Symbols are connected by the flow lines. There are 4 direction arrows, that is up, down, left and right. So as you can see in the previous flow charts, you use these arrows to connect all the different symbols, and these arrows has directions, so that shows how the program flow will move on. And then you have the connector or round box. This symbol is used to jump from the normal line or when some steps needs to be skipped. So this represents the inward or in connector, that is the circle with this arrow direction moving in, and then the outward or out connector with the arrow direction moving out. So this is used whenever you have to skip the program and jump to a different location in the program. Okay, now some examples of flowcharts. So here is, this is a flowchart to add 2 numbers, that is sum of 2 numbers. So you're already familiar with this program, sum of 2 numbers, right? So as you can see here, the beginning, the oval shape, you have to start, and the arrow lines, one arrow line comes. So here you can see that instead of the parallelogram, I have used here the rectangular box, because here as you can see that the values are initialized. A is initialized to value 10 and B is initialized to value 20. So since it is already initialized, the processing is done at the beginning when the of the variables itself. If suppose here you have to enter from the keyboard, if you have to enter from the keyboard, input the value of A and B, then you need to use this parallelogram shape, this shape. Okay, but here since the processing is already done at the beginning, so you are using the rectangular box, and then the arrow line flows, and then the program is processed, the formula logic is processed here. After that, since this is since there is no condition, since this is a very simple program, because this is what you call as a sequential structure program, because directly after entering the value you just execute the formula. There is no need to test is A greater than B or is B greater than A, like that. Just you need to accept from the keyboard, apply the formula, and then print the output, that is print sum, and then after that you just need to stop. So this is the one of the shortest and easiest flow charts. All right, now next you have is a flowchart to find factorial of a given number. I've explained the factorial in the previous algorithms. Okay, so the factorial, if you remember that you to get the factorial of a number, suppose the factorial of 5, then you multiply that number with the preceding numbers, that is 5 into 4 into 3 into 2 into 1. So, or suppose if you have to find the factorial of 7, then you multiply 7 into 6 into 5 into 4 into 3 into 2 into 1, like that. So how do you apply that formula? That is also done in the flowcharts. So you can see that this looks a bit complex, but here you see that you are using almost all of the symbols. So here this is start, and there's only one flow line, and here read n. So you can see that I'm using a different symbol instead of the process box. So here you are entering the value of n. Suppose n is 5. Then after that you are assigning the value fact to 1 and counter to 1. So here you are not using this parallelogram box, but you are using the process box, because you are directly assigning the value of the variable fact and variable counter to 1 1. So now fact needs to be 1 and counter needs to be 1, because as per the formula that is executed here, the fact and the counter is used in the formula, because here fact equals to fact into counter is whatever value is stored in fact and whatever value is stored in counter, that is multiplied and stored in this variable fact. So the old value of fact will be removed, and the multiplication of this will store the new value of fact. That is, suppose like 1 into 1 will store the value 1 here. Clear? So the previous value of 1 will be removed, and the new value that you get here, fact into fact, that is 1 into 1, will be stored on the left side of this variable, that is fact. Clear? So keep in mind that the variable can store only one value. So the previous value will be shifted out, and the new value of fact will be entered in here after processing this formula. So you can see the direction arrows. After that, the comparison is being done. Is counter less than equal to n? So since we need to get a series, right, like 7 into 6 into like that, so for that the repetition has to be done. So based on this, if the counter is, as long as this test condition is true, 1 is less than equal to n is 5, right? So 1 is less than equals to 5. If 1 is less than equals to 5, if yes, then in order to repeat this condition, you use this counter variable, that is counter equals to counter plus 1. So that is 1, since the counter is 1, so 1 plus 1, 2. So that becomes the new counter variable value. So you can see that every time it is added by 1. That is something like if you have to, you are at the stationary point, so let's say 0, and you have to move 10 meters forward. So if you have to move 10 meters forward at a constant pace, so every time you move your feet, you move your legs ahead, you are moving one step ahead, right? So that in program also, to move ahead in the program, you use this counter variable, and it is added by 1. Of course, you can change this also. If suppose you are moving faster, instead of taking one step at a time, let's say that since you are running, you are taking 2 steps at a time. So that can be adjusted by this counter variable formula, that is, say like counter CTR equals to CTR plus 2. So you are adding 2 steps faster, like that. So that can be adjusted with this counter variable, and based on this counter variable, you can see that the counter variable is used for increasing the number, and the counter variable is assigned a value at the start, always will be assigned a value, and the counter variable is used to test the condition. So since the counter variable is the only value that keeps on increasing, that will be tested with the number that is stored in n, 5. Now n, so as long as this condition is true, 1 is less than equal to 5, 2 is less than equal to 5, 3 is less than equal to 5, 4 is less than equal to 5, 5 is less than equal to 5. So as long as, then when it becomes 6 is less than equal to 5, that becomes false. When that becomes false, it comes to the no part, and it will print the whatever value that you get. So let's say that 1 is less than equals to 5, that is true. So counter will get incremented by 1. So now the new value of counter will be 1 plus 1, 2. Then it will come here, and then it will again execute the formula. Fact is equal to, what is the previous value of fact? 1. 1 into 2. So you get the value 2. So you get the value 2. So the new value 2 will be stored in this fact. Previously fact was storing the value 1. So now 2 will be stored here. Got it? And then after that it will come here. Is. Now CTR, this variable stores the new value 2. So is 2 less than 5? Yes. Then when it is yes, then it will come here. Then counter will again increment by 1. That is 2 plus 1, 3. So it comes here. So again this formula will be executed since it is a series, right? So what was the previous value of the fact? That was 2, right? So 2 into 3, so 6. So 6 will be stored in here in this variable, and then 2 will be kicked out. Okay, so 2 will be removed and 6 will be stored here. Again it will be tested. Is 3 less than 5? Yes. Then it will come here. Again it will get increased by 3 plus 1, 4. Then it will come here. Then again it will execute this formula. So that was here, it was 6, right? 6 into what is the value now of counter? 4. So 6 4 24. So 24 will be stored here and 6 will be removed. You get it? So since a variable can store only one value, right, and a variable stores data temporarily, so it does not store permanently. It is just like RAM memory. So as long as a new value is added, that new value will be stored in the fact variable. Then uh, again it will be tested. 4 is less than 5, yes, then it will come here. So counter will get incremented to 4 plus 1 5, so it will come here. So fact value is now 24. 24 into 5, that is, you get the value 120, right? So 120 will be stored here. Then again, now counter has become 5. So 5 is uh, so 5 is less than 5 is less than or equal to n, yes, right? So again this will be incremented, again this formula will process. So as long as this test condition is true, this loop will keep on executing, and when this becomes false, then it will print the whatever output value is, the final value is stored here. Clear? So that way you get the factorial value of 5 6 7 and so on. Clear? So and then finally you will stop the program. So uh, so today we conclude this chapter, that is algorithms and flowcharts. Okay, I'll be uploading some more of the algorithms and flowcharts from the textbooks, so you can go through this and then practice more on that. In the next class we'll start with the next unit, that is unit 4, control statements. Clear? So if you have any problem of this, you can ask. All right.